afternoon, everyone. Am I audible? Good afternoon, Kumar. GNV SKP has joined. Very good. So we will wait for 1 or 2 minutes for more students to come. आप लोग प्रीवियस क्लास में प्रेजेंट थे? राजेश, गुड आफ्टरनून. Have you attended the previous class, lecture 1 of this alternating current? Okay, so I will start today's session. Before going towards the today's topic, Kiran has also joined. We will start with some recall of the previous lecture. In case you have not joined the class or if you forgot something, then we will start with the some of the recall concepts. Okay. So just recall the things. I will not take more of the time of the class. We will recall very quickly some basic punchlines, some basic points that we should remember all the time. Like, first of all, what is AC? What is AC? I hope everyone remembers. Lokesh has joined. What is AC? I'm talking about current or EMF, whatever you want, which is periodic, a current which is periodic, changes continuously, and changes its direction periodically. If these qualities are with any of the quantity, then it may be termed as alternating current, alternating EMF, or whatever it is. So these three quantities, how we have represented the AC in general format, alternating current is represented by, I will say, you remember the equation, I is equals to I naught sine omega t plus minus phi. Omega is the angular frequency, I naught is the maximum value, I is the instantaneous value, phi is the initial phase. I hope everybody remembers this basic equation. Same can be written for EMF. EMF, it can be written as E is equals to E naught sine omega t plus minus phi. Now, these two equations can also be written in terms of cosine, like I naught cos omega t plus minus phi. So there is no problem with that. After this, what we have learned what is the average value. What is the next point that we have considered during the class? That was average value. So you should remember what is average value. Like if I say you want to calculate the average value of current, then average value of current is something you will say integration I dt divided by integration of dt. This numerator portion is generally called as area of IT graph, and this dt is nothing but the time period or time duration. I will say time duration. I hope these two things are very much clear how current or average current is calculated. Now, there were some punchlines, if you remember from the previous class. What were those punchlines? if I recall, for full cycle, if I say, and if current is I is equals to I naught sine omega t, then for full cycle, I will say I average is what? Anyone remembers what is the value of average current? What is the value of average current for full cycle? If current is this one, anyone remembers? Anyone? For full cycle, what is the average value of current? It is zero. What is the average value of current? It is zero for full cycle. Now for half cycle, average value of current was 2 I naught by pi. If current is given as I naught sine omega t, then average value of current during one half cycle is 2 I naught by pi. Now there were few more punchlines that you should always remember, and those punchlines were, if I say, for full cycle, I'm saying for full cycle, average value of sine omega t is equals to average value of cos omega t, and these two values are zero. Always remember, this is the basic punchline, that sine omega t and cos omega t has zero average value for one complete cycle. And similarly, average value of sine square omega t. I'm saying omega t, you can use sine square theta as well. Both the things are same. And cos square omega t, average value is 1 by 2. Bhaskar has joined. Okay, is it clear to everyone? Do you remember, or can you remember these few things? Now there were one more thing, that was RMS current. So what was RMS current? Again, I am saying RMS current. What is the full form of RMS? Root mean square. How it can be written as, this is the most important thing, how it can be written as, it can be written as, take a root mean or yeah, average of I square. This is what IRMS. This is what IRMS, or in under another integration format, you can write it as IRMS is equals to integration I square dt divided by dt. I hope you can remember. If I say what is RMS value for current given, such as if current is given I naught sine omega t, I'm just recalling the thing. If current is given as I naught sine omega t, then what will be the RMS value? And RMS value in that situation, anyone remembers? IRMS is equals to I naught by root. This is another basic formula. Now, the second thing, that important thing that I told you in the previous class, that whenever you were given a supply, or there is a, I will say, some power supply voltage, it is mentioned as 220 volt. Like you see in your meters, like the supply in your houses is 220 volt. So that 220 volt is always RMS value. Or the punchline was AC meters. I will say meters means voltmeter and ammeters, which are designed for alternating currents. AC meters gives RMS value. JNV Ranga Reddy joined. AC meters gives what? RMS value. So if somewhere it is given as 220 volt supply, that means they are telling you the 220 volt is the RMS value. It is not the maximum value. I hope it is clear. Can anyone tell me what is the frequency of the AC supply in our households? Can anyone answer about this? What is the frequency of AC voltage in our houses? 50 hertz. JNV Rangareddy is saying 50 hertz. Very good, JNV. Now, after this revision, we have a question for you and hope you can solve it very quickly. So this is the question on your screen that was given in the homework actually. Amisha was present, I hope, in the previous class. So this question was given in the homework in the previous class. Anyone got the answer? Anyone got the answer? Okay. So I will be discussing this question now. Look at that. They are saying find the average value of voltage. So what is the average value of voltage? You will say V average is written as something integration V dt divided by integration dt. If you can remember the punchline, this portion was the area and this is the time duration. Area of what? Area of VT graph. If it was given as IDT, then it was the area of IT graph. It is VDT, that means area of VT graph. So if you see, this is the area of VT graph divided by time duration. So can you solve the area of this VT graph? I think everybody can solve the area of VT graph. That is half into base into height. That is half. Base is what? 100, but it is in millisecond. So you can write it as 100 into 10 raised to the power minus 3. This is base. Into height is what? Height is 10 volt. This is area. Divided by time duration. Time duration is what? Again, from here to here, time duration is 100 millisecond. That is 100 into 10 raised to the power minus 3. You can simplify this one. This 100 and 100 10 to the power minus 3 can be cancelled. So it will be 2, 5. That is going to be 5 volt. So what is the average value of voltage? It is going to be 5 volt. How many of you got the correct answer? Is it clear? Now we are moving towards the most important thing of this lecture or this chapter, that what is the meaning of leading and lagging. This is the most common word that you will encounter throughout the chapter. Okay. So what is the concept of leading and lagging? There will be two quantities that you will consider most, that is current and voltage, but it can be applied to any of the quantities. But right now I am discussing EMF and current. That's why I will be discussing the same thing here. For example, a situation arises, a statement arises in front of you that I for current leads EMF. A situation arises something like that. Current leads EMF. I leads E. Now, what is the conclusion of this statement? The conclusion of this statement is, okay, before moving to that, at least say yes or no. Am I audible completely? Say yes, so that I can check your attendance. How many of you are present there? Say yes, sir. Randomly say yes, sir. I just Kumar is present. Quick. Ask. Generally, the current and EMF passing of is present. Generally, current is sinusoidal. Generally, current is what? Sinusoidal. the graph and this I am drawing here. Now, one more thing, you see that this graph point is positive direction. This point represents maximum value in the negative direction. Okay, it's not voice. It will be good. Now, I think if it's clear now. So, see two points, maximum points. Current leads E means current, or you can say maximum value of current. You can say in perfect sentence, you can say everybody knows waiting initially. Is it audible now completely? I will reach maximum value before am I audible now? Okay. Give me 1 minute actually. I'm setting things. Just wait for 1 minute. Sorry for that delay. Sorted now. I'm saying if you see somewhere current leads EMF, what signify current will reach maximum value before E. That means if you look at that, this is the maximum value. In current graph or in the graph, it will reach earlier. Like I will show you the next diagram. Look at here. For EMF, this this is the time and this is the time when current becomes maximum. If this is T1, this is T2, then you clearly see that current is becoming for the EMF quantity in braking. It's a serious issue. I'm just turning off my camera for few seconds. Okay. Then let me know what's happening. Give me 1 minute more. Bacha, is it audible now? Sorry for the inconvenience and thank you for your patience. Is it audible now? Okay, thank you. Thank you, everyone. Now listen. Uh, the simple concept is taking too much of time. Very good, very good, very good, everyone, Joel. Now, can you see that the current is reaching the maximum value at time t1 and EMF is reaching the maximum value at time t2. So current reaches before EMF. That means current leads EMF. So what is the conclusion? I will reach maximum value before E. So whenever you want to check if someone is leading or someone is lagging, what you should check? You should check who is reaching the maximum value first. Or one more punchline that I can make here, if you want to draw a graph going to be lead the second one, then what you can do, shift the graph, shift the graph towards left, keeping axis stationary. Now look at that, what I was saying. Can you see that this graph was original graph? Now I want to make a graph which is leading the first one. This is first one, this is second one. So I am making a graph which is leading. So what I did, can you notice that this point has shifted here? That means I have shifted the graph towards left, keeping the axis constant. So out of these two, which is my favorite thing is this one. You should remember this thing. Now, after describing these two things, I am moving for the lagging concept. What is the concept of lagging? I will give you few questions on that. For example, one more interesting thing that you should remember in this situation, I hope that is very interesting thing. If E is equals to E naught sine omega t and current is leading, question says current is leading. That means I will be I naught sine omega t plus phi. I will be what? Sine omega t plus phi, where phi is the difference of phase between the two quantities. How much it is leading? This plus sign indicates that angle is what? Phi. I hope it is clear. Now, one more thing, the concept is lagging. For example, the statement says I lags voltage or EMF. That means current is behind the EMF. Clear? Can you write the same thing as EMF leads current? Are these two statements similar or not? I am saying current is lagging behind or EMF is leading ahead. Are these two statements same? So what is the conclusion of these two statements? What you can conclude, who is leading? EMF is leading. That means EMF will reach maximum value before current. And on this note, I can draw another graph. Look at that. Who is reaching before? Now look at it in this diagram. This graph is for EMF and this graph is for current. Now tell me, EMF, this is the maximum value of EMF and it is reaching maximum value at some time t1. This is the maximum value of current. It is reaching maximum value at time t2. Who is reaching earlier? EMF is reaching earlier. So the quantity which leads also reaches the maximum value before. I hope all these statements are clear. Now in this situation, what you can see, if EMF is E naught sine omega t, then what will be the equation of current? Current is lagging behind, then current is I naught sine omega t minus phi. It is lagging behind by what angle? Let's suppose it is lagging behind by phi angle. Another punchline, can you see that graph is shifted towards right? Graph is shifted towards right. Ultimate thing that you should remember, the quantity which leads reaches the maximum value first. This 90-degree concept or whatever is the angle, it depends. It depends on the circuit, it depends on various things, but generally I am taking it as phi. It may be 90, it may be pi by 2, pi by 4, whatever angle it may be, it depends. Okay. Now there is a very simple question on your screen and I hope everyone will answer. Okay, so there is a graph. Okay, graph is not missing actually. I hope there is a graph. Yes. For the below graph, identify the correct equations. This red one is the voltage and green one is the current. So you need to identify which equation is correct. Four options are there and you have some 30 seconds to answer. I'm waiting for your responses. Kumar is saying option C. JNV on goal is saying option C. Anyone else? Sheka is saying option C. Okay. Akhil, Raju, Pooja, Joel is saying option V. Very good. Joel is saying option B. Okay, so two answers we have. Akhil is saying option A and C. Manikanta is saying option C. C. So most of you are with option C. One is with option B, one is with option A as well. Okay, let's check out. First of all, we will check who is leading and who is lagging. One thing that is sure, we need to check. So if I say this is the maximum value of voltage and this is the maximum value of voltage and it is coming at time t1. And can you see the maximum value of current is this one? It is coming at time t2, which is coming earlier. That means potential is leading, or can you say EMF current is lagging? Clear? That means if you see at the graph of potential, it is starting with origin. And if any graph or sinusoidal graph is starting with the origin like this, then it is going to be V is equals to V naught sine omega t. Note down the thing. If graph is starting at this origin point, then it is sinusoidal graph, I am saying. Then its equation will be sine omega t. Nothing else, nothing more than that. Now current is lagging behind. And if current is lagging behind, then what is the concept of lagging? I is equals to I naught sine omega t. It is lagging behind. That means minus by some angle phi. By some angle phi. And they have shown you that by how much? 1/4 of the cycle. In 1/4 of the cycle, how much angle it can form? In 1/4 of the cycle, how much angle it can form? Can anyone answer? So first of all, your answer is this one, V naught sine omega t, I naught sine omega t minus phi, which is correct option number, uh, which is correct option number C. Very good. Kumar is saying pi by 2. Very good, Kumar. This 1 by 4 cycle means pi by 2. So actually this phi is nothing but pi by 2. But in options, they are dealing with phi only, so we don't need to discuss about that. But you can see that the current is reaching after 1/4 of the cycle. It is mentioned. That means after how much angle it is reaching? After pi by 2 angle it is reaching. So phi can also be written as pi by 2. So this is the correct answer, option C. Clear? Option B means current is leading, but actually current is not leading. Clear? I hope it is clear for now. Next important thing before moving the study, what is phasor? This is the most common thing, phasor. So in one line, I will say phasor are the anti-clockwise rotating vectors. Now, what is this anti-clockwise rotating vector? Sir is creating confusion. No, I am not creating any sort of confusion. Can you notice one thing? The equation of current and EMF were sinusoidal, like I is equals to I naught sine omega t plus minus phi. This is the equation of current. Can you resemble this one? This is same as the equation of SHM. And in the chapter of SHM in class 11th, you have seen, or you must have seen, that a particle moving in a uniform circular motion. If a particle is moving in uniform circular motion, then its projection represents sinusoidal wave like this. Can you see that? This particle, I can't pause it actually. I don't know how to pause it. Actually, it can be paused, but look at that. This particle is rotating in an anti-clockwise manner, and the projection on the y-axis is nothing but the sinusoidal wave. If you see, so that's why what we can do, okay, it can be paused. I don't know how. What I'm saying, okay, 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 I can play with it. Okay, now look at that particle at, array. Okay, don't worry. You can see that particle is moving, then its projection is representing the sinusoidal curve. That's why we are taking it as a anti-clockwise rotating vector. So EMF and current both can be represented with this anti-clockwise rotating vector like this. Okay, I can't write. Now, what are the punchlines of this phasor? Look at that. I will tell you how it can be drawn. EMF and current are represented by anti-clockwise rotating vectors. One important thing. Next important thing is what? Length of the vector represents peak value, and the projection on y-axis represents instantaneous value. So this is going to be a confusing thing for you. Now listen to me. Now listen to me. I am saying you have some equation. E is equals to E naught sine omega t. And you want to draw a phasor for this. What you can do, first of all, draw XY axis. Clear? Draw the X and Y axis. This is your X axis. This is your Y axis. Next thing, draw a vector starting from the origin. Clear? And give it an angle which is equal to the phase. At an angle equal to the phase, draw a vector. This angle in the anti-clockwise direction is the phase, which is omega t. And this is known as EMF. And the length of this vector is what? E naught. What the statement says, length of the vector represents peak value. Peak value is what? E naught. And the projection on the y-axis, this projection on the y-axis gives instantaneous value. Instantaneous value means this is the instantaneous value. I hope this statement is clear. All these three punchlines are clear to you. Similarly, if a equation is written as I is equals to I naught sine omega t plus pi by 2. If it is written something like that, then can you see that current is leading the EMF by some angle pi by 2? If current is leading the EMF by some angle pi by 2, then how can you draw the current? You can draw the current like this. And this angle will be 90 degree. 90 degree means pi by 2. And this is what? I naught. The length of this vector is what? I naught. And its projection on the y-axis is what? Instantaneous value of current I. I hope you can draw the phasor diagrams. Clear. Okay. Moving further. Now, there comes AC circuits. This is again a very important part of this chapter. We will have some 6 or 7 circuits. I will say 7 circuits. And after completing these 7 circuits, it's done from our side. Clear. Now, I will not derive the equations. What I will do, I will give you the punchlines or the conclusions from this circuit. What are the conclusions? Like suppose, first of all, this is the AC source connected. And in this AC source, there is a resistor connected. Some current will flow through the circuit. Like suppose current is moving in the circuit is I. Then what is the punchline? First punchline is EMF and current will be in same phase. Will be in same phase means current and EMF both will reach its maximum value at the same time. Can you decode the meaning of same phase? Both will reach the maximum value at the same time. Clear? Now, if they are in same phase, then how it can be written in terms of equations? Equation of EMF is given as E is equals to E naught sine omega t. It is given. You can see in the diagram, it is given. Then equation of current will be what? I is equals to I naught sine omega t. Because both are in the same phase, you can check the phase of both is same, sine omega t. Now, what is the next important thing? The next important thing is how you can write the current in the circuit, or the maximum current is equals to. Do you know Ohm's law? Anyone knows Ohm's law, remembers Ohm's law? I is equals to V by R. I is equals to V by R. So I am writing I naught. Very good, Joel. V is equals to IR, or I is equals to V by R. So I am trying to write the maximum current. So this is potential by resistance. And can you see that potential is maximum I know E naught. So I will put maximum EMF divided by the resistance. So what is the maximum current? E naught by R. And if someone asks you what is the RMS current, then do nothing. Just apply Ohm's law, but put the value of EMF as RMS value divided by R. So IRMS is what? ERMS by R. I naught is what? E naught by R. What is the punchline? EMF and current will be in same phase. Now, after knowing these two things, one thing, their phase, their equation, the maximum current, the RMS current. What what is next? We can draw the phasor diagram, we can draw the waveforms. So on the next slide, you can see the waveforms. Look at that. Can you see that this green graph is for current and red graph is for voltage, and both reaching the maximum value at the same time? Let's suppose this time is T1. Both reaching the maximum value at the same time. That's why it is known as they are in same phase. Now, how the phasor diagram can be drawn? Look at that. This is not T1, this is just omega T. Can you see that voltage and EMF both are in same phase, both have the angle of phase angle as omega T, both are in same phase. This is phasor diagram. This is waveform. Okay. Now, I hope you have taken the screenshot or you have written everything. Moving further for the next circuit, this is purely inductive circuit. What is purely inductive circuit? In which only a inductor is there. This is the inductor, and a purely inductive circuit is something like that. This L is what? Inductance. L is what? Inductance. You have learned about inductors and inductance in previous chapter, like in EMI. Okay, another thing. What is the punchline? So what is the punchline in this circuit? The first punchline, EMF leads the current. In this circuit, EMF leads the current. By what angle? By pi by 2. This is the first punchline. Now, after knowing the concept or the punchline, you can write second punchline. If according to the diagram, EMF is given as sine omega t, E is equals to E naught sine omega t, and EMF is leading. Can anyone write the equation of current here? What will be the equation of current? I need some answers from your side. What will be the equation of current? Just give me the phase angle. You can write W in place of omega if you can't type omega, and phi or the angle is pi by 2. Can anyone write omega t minus pi by 2? Okay. Akhil is saying omega t minus pi by 2. Very good. Very good. Very good. Okay. You guys are very good. So EMF actually leading the current. But can you see that the conclusion is current lag the EMF? Both the things are same. That means I is equals to I naught sine omega t minus by what angle? Pi by 2. Pi by 2 means 90 degree. Very good. This is the equation of current. After knowing these two punchlines, one is very important thing which is left, that is maximum current. What will be the value of maximum current? And if you apply Ohm's law, then it will be potential over resistance. Potential over resistance. So potential is what? E naught. Resistance of inductive circuit is denoted by XL. And this XL, anybody knows the name of this XL? This XL is known as inductive reactance. What is known as inductive reactance? Very good. What is the formula for this inductive reactance? The formula for this inductive reactance is omega L. Write down everything. XL is what? Omega L. What is omega? Omega is the frequency of the source or the angular frequency of the source. And XL is what? Inductive reactance. Its unit is what? Unit is what? Anybody knows the unit of this inductive reactance? Very good. Unit is ohm. Kumar is saying ohm. Very good. So I agree with Kumar. It is ohm. Now, as you see the unit, it means it is resistance. And if it is resistance, then there is one more situation, one more conclusion, that this resistance depends on the frequency of the source. That means this is not the normal resistance. This resistance depends on the frequency of the source. Higher the frequency of the source, higher is the resistance. Clear? Okay. Is everything clear in this equation? You can write down everything. Now, I'm drawing on the next screen. I will draw waveforms and phasor diagrams. Before me, try to draw it by yourself. Look at that. This is purely inductive circuit. Red one is EMF. This is current. It is already mentioned actually. Why I'm writing it. Can you see that EMF is leading, current is lagging, and the phasor diagram is drawn something like that. This is potential, this is current, and can you see that current is lagging by some angle pi by 2? Okay. On this note, I am giving you a question. Okay, so first of all, just answer me. Just answer me, type your answers. In purely resistive circuit, who leads or who lags? In purely resistive circuit, who leads or lags? Both are in same phase. You should answer both are in same phase. In purely inductive circuit, who lags? Quickly. In purely inductive circuit, who lags? Current lags. Very good. Very good. Now there is a question on your screen. Just solve it. You have some, I will say, 40 seconds to answer. There are no options actually. So what you can do, just give me the answer of this peak value of current. Just answer one part. What is the peak current? Kiran is saying 10. I am asking peak current, Kiran. Peak value of current. You are telling me the peak value of voltage, I hope. Okay, let me check. Who will answer first? Who will answer correct? Who will give the correct answer first? That matters. And for me, it's more important than you if you answer. Okay, still counting. Okay, we can start. Inductor is 5 Henry. First of all, I am just drawing a simple circuit, 5 Henry inductor, and there is an AC source. This is an AC source. Some EMF is given here. Now, question says find peak current. What is peak current? If you say what is peak current, I know Ohm's law, I is equals to E by R. In inductive circuit, R is what? XL. And for maximum current I naught, then E naught must be here. I know the value of E naught is 10. You can see E naught is what? 10. Now I need to calculate XL. So what is the value of XL? So I naught is equals to E naught by XL means omega into L. From this equation, you can see omega is 10 and L is given as 5. So you can put the values E naught is 10, omega is 10, L is 5. It can be cancelled, that is 1 by 5. So what is the maximum value of current? 1 by 5. Very good. Is it sinusoidal? Yes, it is sinusoidal. Then what is the RMS value? What is the RMS value of current? You can say IRMS is nothing but I naught by root 2. I hope you remember this one. Now put the values. I naught is what? 1 by 5 root 2 is the answer. This is your RMS current. Next question says what is instantaneous current? So instantaneous current is what? In general form, the equation of current is I is equals to I naught sine omega t plus minus phi. This is the general form of equation, general form of current. In this equation, this I is known as instantaneous current. I am not writing it completely, instantaneous current. So you generally the question is asking you to write the equation of current. So I am writing the equation of current. There is no problem with that. And I hope you can also write. I is equals to I naught. So what is I naught here? Can you see I naught is what? 1 by 5. 1 by 5 sine omega t plus minus phi. What is the phase difference? This is purely inductive circuit. In inductive circuit, current lags behind by pi by 2. So what is the original phase? Tan t plus pi by 6 is the original phase. And this current will lag behind by how much angle? Pi by 2. Is the last statement clear to everyone? How this minus pi by 2 is coming? Is this statement clear? This is your answer. Is this statement clear to everyone? Very good. So this is the easiest question. You can do it very quickly. Of after this, in the next class, we will complete the AC circuits like LR, LC, LCR circuits. We will discuss about some resonance conditions, quality factors, and some very important questions. In the weekend class, there will be a question discussion of AC and EMI. Uh, so do join us in the weekend classes. Very good. I hope that's it from our side for this session. See you again tomorrow. We will try to complete the AC. Till then, bye everyone. Thank you, Bacha. Thank you, Santosh. Thank you, Amisha.